Hey everyone, this is the second part of the lesson 7-4. So I had some software problems that last on the last problem my software crashed. So this is just the last part of that lesson. I wanted to look at a story problem in here, and so you'll see some story problems as part of your homework. And so so here's some like an application of a rational expression. And so this is talking about rates. Okay, when we talk about rates, we're talking about rational expressions, right? A rate is something divided by something. So usually it's something over time. So distance over time, or miles per hour, or how the rate of work, right? I can paint 4 houses, in 3 days or something like that. So talk about rates, okay? And so you'll see some problems like this where they'll ask about rates, and really they're asking about combining rates. Okay, so if if I say, well, one person can paint a house in 14 hours, another person can paint that same house in 9 hours. What if they were working together? What would that rate be? All right, how fast could they paint that house? And so you're combining rates, and you're trying to figure out a problem like this. So let's take a look at this problem. We're looking at an inlet pipe. Okay, so it's filling a pool. So it starts with an empty pool. It starts filling it up, and in 6 hours it fills it up to the top. All right. Now separately, we've got a drain over here, right? And when that drain's open, it takes 8 hours to drain the whole pool. Now, we don't know how many gallons are in that pool. We don't know how many gallons, per hour it's going. All I know is that in 6 hours, it's going to fill that pool. And when I open that valve in 8 hours, it would drain that pool completely. All right. So what we're going to do is we're going to talk about rates. And so I'm going to talk about the fill rate. Okay. So fill. So the fill rate, right? It can fill one pool in 6 hours. Okay, so we could say that rate is 1/6 of a pool per hour. Right, so that's the fill rate. It can fill 1/6 of a pool every 1 hour. Okay, so in 6 hours it would fill the whole pool. And I can talk about that drain pipe, and the drain pipe drains it, right? It removes water, and the rate on that, well, it takes 8 hours to drain that pool. So the rate is 1/8 of a pool per hour. So here we have pph, pools per hour. All right, now, what does our situation say? Our situation says that we have both of these happening at the same time. So it's filling, right? And then it's also draining. And so they want to know if somebody, tried to fill that pool and they forgot to close the drain, how long would it take to fill that pool up? So we have water going in at a rate of 1/6 of a pool per hour. And we're going to say that T here represents the number of hours. Okay. So number of hours to fill the pool. All right. Now we don't know how many hours it's going to fill because we got water draining out at the same time water is coming in. But I know it's going to be 1/6 times whatever that number of hours is. So that's going to be the fill rate. All right. And then we have also water flowing out of it, so we're going to subtract. So we're going to subtract, and it's subtracting at a rate of 1/8, right, of a pool per hour. So multiply that by the number of hours, and it'll tell me, how long that takes. And how many pools am I looking to fill up? Well, I'm looking to just fill up one pool, right? So we're looking for that pool to be equal to 1. Okay, so here is my rational equation, right? And so I want to go and look at, how we can write this out. All right, so now I could just say, well, I can find a least common multiple. and I just multiply those together. 6 times 8 is 48. However, that's not exactly what that's going to be, because there are smaller numbers that 6 and 8 both go into. And so I'm going to just kind of go through the process. I can write 6 as 2 times 3, and I can write 8 as 2 times 4. Okay, and so and I can also write 4 as 2 times 2, right? So this is actually 2 times 2 times 2 and 2 times 3. So let me actually erase this here. So I'm going to write this as 2 times 2 times 2. Okay, so here I have 3 2's multiplied together. Okay, so in order to get this to cancel out, I'm going to have at least an 8. I'm going to have at least 3 2's multiplied together. And then I also need a 3, right? A 3 to multiply those together. So really, I'm looking for 3 and 3 2's, right? Which is 3 times 8, which is 24. So my least common multiple here is going to be 24. Okay, now you probably could have, just gone through and sorted through that, right? What are the multiples of 6 and what are the multiples of 8, and find the one that they have in common. That's the smallest one. That's the least common multiple. But this process of finding all these factors and then making sure that we have each of those factors in our least common multiple is a good practice to go through, especially when we get into larger, more complex polynomials, right? When we have quadratic and cubic and that sort of stuff. Finding those factors is going to be an important thing here. So I'm going to multiply everything by 24. So I've got 24 times t over 6 minus 24 times t over 8 is going to equal 1 times 24. Multiply every term there. 24 divided by 6 is going to be 4t. And then 24 divided by 8 is 3t, so minus 3t. And so that's going to be 24. And so when I combine those like terms, I get t is equal to 24. So it looks like it's going to take 24 hours. Right? So if somebody left that drain open and tried to fill that pool and didn't check on it in 24 hours, that would be full. Okay, so whenever you come across a thing like this where they're looking for combining rates, right, make sure you write out those rates. You're going to write those out as fractions, and then do whatever the problem says. Sometimes you're going to add the rates, sometimes you're going to subtract the rates, but the problems in your homework assignment, you're going to see some problems like this. All right, so I'll go ahead and finish this video here, and please let me know if you have any questions.